So we're obviously back up on the bench, and we're going to start assembly of the Altair-Duino 8800 little emulator front panel project. Make sure I got, that's the wrong glasses. I need the right glasses here. We looked at all the components in a previous video. I've kind of planned these videos out a little bit. I think there's going to be a number of videos in the assembly here to kind of keep them shorter. In this video we're going to tackle resistors. So let's go ahead and get down to the PCB. Get the case out of the way. Sorry, I'm setting things aside off camera. We've got the assembly manual here. I've also looked through this on their website. So we're going to start with the bag of 1K ohm resistors. I know this says 150 ohm. He increased the resistance to make the LEDs dimmer intentionally, and good idea, I think. This is kind of the kind of errata you need to keep an eye on as well. Well, can I get the baggie open, or do we just need to call this quits for the day because I can't get a grip on it? I hate these little baggies. Come on, open up. We've got a fair number of them. We can get them all out of the bag. One left, so they are, you can already see brown, black, red, so they are 1K. We will form the leads here, which always takes time. As you know, I tend to do this by hand. I don't know if I've got a lead tool that'll give me good width for these. I actually do. It's a little nicer build if you use a lead forming tool. Maybe. Let's just see. No, that gives me good spacing. So I guess I will just spend the time here and form these leads. This will take a bit. Looks like this is going to be a pretty fun project overall. A couple people have already expressed in the unboxing video comments they're looking forward to seeing the build. Trimmed my fingernails yesterday, and so I don't have anything to get up underneath the resistors with to make it easier to pick them up. So those of you that have followed along on the channel from inception or have discovered it, I've been doing this for about 2 years now. We're someplace over 200 videos, crossing a large number of subjects. I think I've achieved something in the range of a little over 70K views in 2 years. I was told early in that it would take 2 years to get to 500 subscribers. We've exceeded the 500, which is nice. We're a little bit over it. I believe I need to get to 1,000 subscribers and 100,000 views before I can enable monetization on the channel. As much as I hate to do that, there is expense with the channel. As I've said previously, you know, almost everything I've done on the channel is work I would have done normally anyhow, so it's really about sharing with everybody. That one didn't work very well. At the same time, if the nuisance of an ad or two at some point can bring in a small amount of revenue to help fund the channel, that would be really useful. I think, you know, I'm not asking for money on Patreon or anyplace else. I've had a couple people over the 2 years offer donations of hardware. Neither one of those actually panned out. Shipping prohibitively expensive on large computer stuff, especially when it's coming from like Florida. I do though very much appreciate the offers. If people have stuff they'd like to donate, you can always get a hold of me at the shadowtronblog@gmail.com, or even in the comments. You know, if it's something interesting, I may help with postage. I don't ever expect the channel to, you know, get to the kind of size that like the EEV blog channel is, just because you know, my subjects are so diverse. It's not really meant to be as much as a, you know, an engineering channel as much as just a hobbyist channel for whatever seems interesting at a moment in time. I have considered doing more kit builds on the channel. I don't know if it would be worth, you know, some of the inexpensive Chinese kits on eBay if people would like to see an assembly video of assembling some of those simpler kits. I could certainly do that. My most popular videos by far are on subjects I don't personally have a ton of interest in. You know, they were things I needed to do at the time to get a project done, or to provide infrastructure I needed. The Ansel videos have done fairly well for me. But again, that was bought just to migrate my personal web stuff away from GoDaddy, just on-prem. I haven't built that Ansel system out nearly as far as I'd planned to. Really lack of time. And a lack of really, you know, I don't need the stuff I want to do on there. It's all nice to have. If people have opinions about maybe setting up a Patreon, if people would like to donate $1 or $2 a month, it would help. So I do have some expenses with the channel. Obviously you do. So we've, I think, formed the leads on all of the 100 or the 1K ohm resistors. They are going to go in R1 to R36 according to a little manual here. I'm swapping glasses here as I always am. See if I can get a hold of one here. There's R1. R2. This stuff always takes longer than you think it will. I am, as I always do, putting these in with the orientation of the resistor the same way. They're non-polarized, it doesn't really matter, but as I've said in many previous videos, I just think it's a little nicer build if your resistor orientation is all the same. You know, I've looked a little more at this PC board off camera, and it's a nice quality board. You know, it will do the job. You know, for the price point, it's a nice little kit. I think in the Ken Back video I commented that I know just how hard it is to kit out. You know, to design a kit, to get all the components together, to bag them, you know, sort them, bag them, verify them, provide support for users who get into issues. Occasionally a component will get missed in a bag and somebody will ask for a replacement, and so you're doing postage and all those kind of things. It's a huge effort, and I would guess the designer of this stuff isn't making a ton of profit at it. I hope he is making a profit. That always helps. But just kind of give him a nod of appreciation here, because I know the effort it takes to put something like this together and to support it. Like I said, 15K, but it was 150 ohm again, or 14. We're not even halfway through yet putting all the 1K ohm resistors in. Or 15. Or 16. Lead's a little overformed on that. Did I just pop one out accidentally? I did. R16 jumped out. R16. R17. And R18. I think that's half of them. Now this is where this always gets tricky. It's not popping all the leads loose. Hopefully that'll sit there. And every time you see me do one of these, I use a different method. In this case, I'm just going to use some blue painter's tape to hold those all flush. We'll flip the board over and solder the first 6 or 18. And as I typically do, I'll solder one lead, flip the board over, just take a look to make sure they're all kind of lined up and square, and I'm happy with them. Straighten anything out that I think needs to be straightened out, then come back and solder the other row or the other pin on each resistor. You know, if people have comments, questions, whatever, I'd like to hear them. I'm not always super quick on getting to the comments. Life and projects gets in the way, and work. So I believe that's one lead on every one. Tape is very reusable. Bit of twist in some of these. That's just because I didn't form the leads as squarely as I should have. Generally that looks good. We'll hit the other side. Fair number of components on this board, although the layout's very generous. It's all through hole. I wouldn't recommend this necessarily as a beginner project, although if you had somebody with some assembly experience and were a beginner, just answer questions, provide guidance, etc. I think it's definitely an approachable project. Again, if you're an absolute beginner to soldering, I think it's a good investment just to spend a few dollars and buy one of the Learn to Solder kits where you just, you know, it's really just about soldering. Through here and trim leads. I'm sure you can't see that squarely. I'm taking the leads off 2 at a time just because the majority of them are very close together, and that works. These leads are pretty soft. and I'm not actually using my thumb, as you've seen in previous videos, to catch the lead as it flies off from being clipped. I am obviously not clipping towards myself here, and I do have glasses on, so it's pretty safe. Now we move on to we got through R18, and it's 19 on to 36, which is another row. Silk screening on the board's nice and easy to read. Which always helps. I was watching a oscilloscope repair video this morning on the EEV blog, a Tektronix scope, a nice scope. One of the things Dave commented on was the component locations weren't silk screened in the power supply board, requiring you to look at visual drawings. So somebody that goes to the effort to actually put silk screening on a board like this and identify all the components and that kind of stuff, again, it's work to do, design boards, work to make sure you've got it correct, etc. Again, it's just one of those things that's very much appreciated when the board's designed. Attention to detail. Etc. You know, just makes assembling a kit like this a nicer experience. R30. R31. R32. Almost through the second row here. Now, I did not do an inventory count up front, just because I didn't see the need to if I was short a resistor. I've got plenty here in my stock. There appears to be an extra resistor, which is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So whether there was an extra in the bag or it gets used someplace else, I don't honestly know. Let's see if we can reuse the tape from earlier. Of course, this piece here wound up pretty tight on itself. Blue painter's tape, it's a blessing. Really helps with this kind of stuff. And same thing as before, one lead on every resistor. Tape off. Quick visual inspection. Tweak anything that's grossly out of alignment. Solder the other pin. If you soldered both pins and a resistor was crooked and you grabbed it with a pair of needle nose just to twist it to straighten it out, you're creating mechanical stress. Where the leads enter the package of the resistor, you're creating mechanical stress in the solder joints. It's just a great way to induce a failure at some point. One of the resistors pulled out with the tape, so I must have got one lead captured on all of them. The values on a couple of those looked funny in the light, but now that I've got a little better light, they look fine. Don't know that I have all of this 100% on camera. It's a fairly large board. This kind of work here, you know, if you were back in the 70s and actually bought an Altair 8080B kit, you would be doing exactly what we're doing here. The front panel, as I recall, in the 8800 was about the same size as this PCB, and you would have been working with through-hole components, so it's, I imagine it's a little bit like that experience would have been. Got you. Well, it's kind of a nice throwback to that era. As much as I would have liked a system like that back then, I couldn't afford it. So I was a teenager and I couldn't convince my parents that it was a worthwhile investment. I remember my mom saying when I was about 16 or 17 that she didn't understand this computer stuff, there was no future in it. And of course she was wrong, but I understand why she made the comments. I couldn't have imagined then that we would be at the point we are now with, you know, ubiquitous computing, you know, gigahertz machines, pretty inexpensively. So that really does cover R1 to 36, or the border's labeled 150. Yep. Going to move on to the 10K next. Wherever they ended up. So I will form the leads on these off camera, and then we'll come back and solder them. So I've gone ahead and put in all of the 10K ohm resistors from R37 to R72. There were 4 left over that are in this little bag here that I think get used later on based on what I see in the silk screen. And this is the 1K ohm resistor we had left over, which may be used later or not. I put it into a bag before I did anything with the 10K ohm resistors just so it wouldn't get mixed in accidentally. In this case, I've just stuffed them all and taped them all, and I will kind of solder them in one larger batch. And we'll go ahead and do that on camera here. And some people seem to enjoy watching soldering. I'm going to kind of follow the same process, one lead on each resistor, pull off the tape, quick visual, go from there. With this many resistors on the board, it's a lot of leads poking up through. I did manage to drop one of the 10K while I was forming the leads on the floor, and it was quite an effort to find the damn thing. But eventually found it. Did I not? I've got plenty of 10K ohm resistors in stock, although it may not have looked the same, and the purist in me would like to have it look the same. Go through the row towards the top of the board now. With practice on kits, you'll get much better at being able to flip a board, you know, front to back, and very easily see where you are on the board. It just takes a bit of time to do, or to learn how to do. So if you're struggling as you flip the board over, having that cable walk along with my arm isn't useful. Just be patient, the skills will come. The solder's getting hung up on some of the other leads. Hopefully now the resistors will pull out, which means I did get one pin soldered on all those. And same here, so there's that block of 10K ohms stuffed. Just kind of looking at them for alignment. Not critical. But, you know, a little tidier is always better. I'll know, even if they're hidden behind the case, that I spent a little bit of time to just kind of try to make it look a little visually better. You know, the tin plating on the board is really good. These are soldering up very easily. I'm not fighting any leads anyplace. Picking up stuff that we're going to be assembling going forward. The sea of leads makes this a little bit tricky. When I was soldering the row below, the solder in my hand kept touching the leads up here, and now that I'm trying to solder the leads up here, the soldering pencil keeps touching the resistor leads below. It's kind of the downside of stuffing this many components at one time to solder. But, you know, pretty straightforward assembly. Right at the edge of not being able to focus through my close-up glasses at this distance. Hopefully my big old head isn't getting too much in the way. I missed a resistor, or one of them fell out. That's interesting. I have to come back and revisit that spot. Yeah, I missed a 10K ohm. So we'll add him back. Yeah, I missed one right here. Let's go ahead and trim these leads. And there is kind of the downside of doing so many components at once, is it's easy to miss one. I actually didn't notice that I actually soldered an empty hole there on the board. It didn't have a lead poke through it. Again, I am wearing safety glasses. Well, not safety glasses, reading glasses, but there's a lead I missed soldering. So what you're seeing here is a couple of the different issues when you stuff so many components in one pass. As I did. This guy right here didn't get soldered. These are the kind of little things you'll get it put together and one LED won't work, and you'll look and look and look. And sooner or later go, oh, I missed a solder joint, or I missed a component. You know, stuffing these a few at a time is probably the safest approach. I guess I'm too impatient for that. That's a lot of leads. Let's go ahead and put in the resistor we missed. Well, I didn't mean to dump all of them out. I only wanted one. Looking for my solder wick. There's only 20 rolls of it floating around here. Where are they? Huh. That's really weird. They should all be sitting there on the shelf. Did I use them for something else? I'm gonna just pull the solder back up out of the one hole that I accidentally soldered without a lead in it, just to make it easier to drop the part down in. At least that's the intent here. Whether that's going to work in reality is a different question. Yeah. Prop the board up. This orientation is this way. Of course, this assumes, actually, we're going to cheat a little bit here. I'm going to shorten the lead that's going down into the hole. That's full of solder, and that way the other lead will already be being guided in. And I'll just push him down in place. As the solder wick didn't want to pull the solder back out of that hole. So the resistors for the transistor drive circuit for the LEDs all seem to be in place. My guess is using these as level shifters, or well, I shouldn't say level shifters, but as drive for the LEDs. There'll be a transistor at each LED as well. Let's see what he has me. So he really has us move on to the transistors next, and we're going to do that in a different video to try to keep these segments somewhat short. This one's probably already going to be 45 minutes or so, which is pretty long. So anyhow, we'll come back in the next video and tackle the transistors.